Hey, how you doing?
Hi, Jacob.
Welcome back. All right, so we got a new section. We're going to finish out the stuff on angles today so that we can continue forward. You will need scissors and glue, various writing utensils. If for some reason you did not keep the little cutouts from the last time, which is okay, I know it's been like a week since we worked with them, you may need to draw them. If you are in that position where you're going to have to draw the little cutouts today, I urge you please get a straight edge so that way your pictures are perfect. Start off the day by updating your table of contents. Try to make sure your page numbers are there. Please, unlike me, I am lame. All right, Porter, I think you should just go for the slam dunk at this point.
I did.
Okay. All right, we're going to flip through to find the page to start the notes on. Here we go. Lots of blank pages for table of contents stuff. We've got all the things here. As you're flipping through, keep an eye out for anything that seems like it's coming up or not sticking very well. And take a moment right now to go ahead and just re-glue that down. Make sure it's not going to go anywhere on you. I'm going to have quite a lot of those because I don't glue very well when I'm doing lecture. I just put like one dot of glue and then move on, and so I don't really glue my edges. So. Yeah.
Let's say I factor down a radical.
Okay.
What would my justification be? Like when you factor down, that's your answer, right? When you get to the final.
Right. So stuff like, did you use any of the properties, product property or quotient property? And then that you picked factors. That would be the best way to do it.
Basically factor it down to the radical to its simplest form using
Whatever properties you use.
Miss, what page is it for you?
All right, let's see here. My construction for angle bisector was page 30. We need to leave the next page for a KWL for that particular assignment, which was Chapter 1, Lesson 4B. So you'll want a KWL space for that. You will be getting your tests back graded today, and I will need you to have a KWL page for that test. Okay? So that way you can go through and make sure that you're feeling comfortable with those items.
Probably going to have to be after this one because...
Okay, because you already begun? That's fine. All right, and so we're going to use the next page to start today's notes. So go ahead and prep this page. I will give you 2 minutes to prep. As always, the title for the lesson is on the projector just beneath the La Feria logo. Objectives below that. If you cannot read the projection for the objectives, they are listed on the whiteboard just to your left of the projection screen. Today is the 30th of September, so I will be waking you up now that September has ended.
After September.
Oh, that one got applause! Yes!
Good job, Good job.
Thank you.
Because the Green Day song is Wake Me Up in September.
Yeah, Jacob, it's only funnier after you explain it, Jacob.
Oh, Roy didn't get it.
You got it!
I never heard that song, but okay.
I will put a link in the doobly-doo description thing under the video when I put it on YouTube for to that video.
And subscribe.
So that you can get the joke, yes.
I wouldn't do that for copyright.
No, I'll include the link.
Yeah, just the link won't do anything.
Yeah, I'll include the link in the description below. In the this one channel that I have, he calls the description under the video the doobly-doo. I love that. I don't know why. The doobly-doo. So I'll put the link to the video in the doobly-doo.
You have to also put the link to that guy's channel now.
To that guy's channel? Okay, to where I got the doobly-doo.
Yeah.
All right, I have a feeling this is going to be the tape that gets uploaded because I got the best reaction on that one.
Yeah.
All right, let's go ahead and kick off the day with an example. Out of deference for those who may need to copy this down, I'm going to rewrite the letters. That's a T, that's a Q, this one's an R, and this one's an S. And this will be an example. Throughout today's lecture, you're going to see me switch hands, so my writing is going to look weird once in a while. It's because I'm trying not to cover the graphic in case there are people who need to copy it down by hand. Okay? So if you see me switch hand and the writing gets weird, that's why. All right, you've been asked to find the measure of QRS. What are you going to use to do that?
QRS, you're going to add.
Is that what that's called?
You're going to add the angle measurement of QRT and TRS.
So which you said you were going to add the measure of QRT and the measure of TRS. And when we do that, it's going to give you the measure of QRS. And as was commented, that is using the angle addition postulate. This is a recall moment, so please add your recall symbol. And then off on the left, you want to put the symbol again, and we'll go find the lesson code for that. I'll give you the lesson code in a moment. All right, the measure of QRT is 40. Measure for TRS is 83. Degrees. Oh yes, I mustn't forget my degree symbol. I'm really bad about that. And when I add them together, it'll give me the measure of QRS. 40 plus 83 is 123, I heard in the back. There you go.
1, 2, 3, miss.
One-
As easy as that.
It is easy as 1, 2, 3. As easy as 1, 2, 3. A, B, C, you, and me. Name that artist.
Jackson 5.
Jackson 5! Just shout it out!
I was going to say 70s Michael Jackson.
70s Michael Jackson, better known as the Jackson 5. All right. Puberty. All right, this is the first big vocabulary word for today as we talk about the relationships of angles. So out of deference for those who may need to write down this, I'm going to write down adjacent angles here on the left. But I'm doing it with my opposite hand because I don't want to cover the graphic. Have you heard the word adjacent before?
Yes.
What's it mean?
Opposite angles.
Equal. No. Next to each other.
Next to each other. Awesome.
Miss,
Yeah.
is it true that if angles are not adjacent, but they are parallel, you can work the problem as if they are adjacent?
Okay, I see what you're going at. The short answer is yes. The long answer is give me a couple units and we'll explore exactly why. So we're going to go with an informal definition for adjacent and say that we're going to have it mean next to and connected. Okay? So these angles are adjacent because they're next to each other and they're kind of smashed together. They share a ray, a side of the angle. And these over here are not adjacent because they do not share a ray and they are not next to each other. In fact, these two angles could be on other sides of the planet and no one's going to care. Okay? Next graphic. I've got to find my next graphic. Here it is. Next graphic is the one that looks like an X. Off to the left, the vocabulary word is.
Teachers, at this time, please release all the seniors with the letters from R through Z to report to room 403. R through Z, all seniors. Thank you.
All right, so this relationship is vertical angles. I'm just copying from my graphic. Now, what do you notice about the vertical angles of this graphic?
There's no arrows.
There's no arrows. What did you say?
They're all different.
Oh, they're all different. Yeah, what did you say?
Oh, on top.
There's some on top and there's some on bottom? Okay. Okay, there's some verticalness going on right here.
And horizontal.
There's some horizontal going on. They may or may not be perpendicular. They kind of look it, sort of.
Intersect.
Miss,
Intersect.
They can't be perpendicular.
What are intersecting? We'll get back to that in a minute.
What are intersecting?
Yeah, he said intersecting. What's intersecting?
Two lines.
What
Yeah, we got these two lines, and they're forming this point in the center. Yeah, so vertical angles are going to be created by two intersecting lines. Do I need to zoom in more? Or is it big enough? So vertical angles are going to be created by two intersecting lines. Now, the vertical angles, they're going to end up in a picture that looks like this, but this picture isn't vertical angles. The vertical angles are a pair of angles. In particular, they're the ones directly opposite a vertex. C and E are vertical angles. Which other pair of angles could be vertical in this picture?
D and F.
D and F, very nice. After you're done writing, I would like you to look to an adjacent partner and be like, bruh, angle C and angle E are vertical. Get the whole sentence in there, though. They're vertical angles. Now to turn to someone not adjacent to you. You can totally be across the room if you want. And tell them about D and F.
Bruh, angle D and angle F are vertical.
F and D. F and D. Yeah.
What about them?
Vertical, right? Yeah. Something.
Say it. They're vertical.
Vertical.
Miss,
There you go. Put the
Miss,
phone
you
away.
should change angle D
Put
to
the phone
angle
away.
H.
Put the phone. No, put it away.
I'm doing
Okay, later.
Why?
Dude, just do what she says.
Work with me right now with this.
Why?
Miss, you should change angle D to angle H.
Oh?
Yes, so that way we can be like F and H are vertical.
I don't get it, but okay. I have one last comment to make about vertical angles. Sorry. Over my head. Look at C and E. What appears to be true?
That they're vertical.
They definitely are vertical, and you're exactly correct. But what else, just by looking at it, what might be true?
Vertical angles are congruent to each other.
They look like they're the same size, no? Like if I were to fold this paper this way on that vertex,
Symmetrical?
yeah, it would be symmetrical. They'd line up, which makes those angles congruent. So we're going to actually take that exact sentence that he said and write the vertical angles are congruent. We will soon prove this statement. This is not a postulate. We can't just assume it's true. You can't just believe me on it. We actually have to have some proof. So I want you to draw your little look forward eyeballs, because very soon you're going to have to write the proof for that. Find the next graphic. And off to the left, to go ahead and write that, put a star and write linear pair. Out of deference for those who need to draw this graphic, I'm going to be writing the left side with my left hand, so it doesn't cover up what you're doing. I apologize for the messy handwriting.
Miss, so we can't see it.
I know. I'll scoot it. I'm just writing this. All right. What do you notice about this linear pair?
If you add them together, they're 180.
They share a ray.
They share a ray. You add them together, you get to 180. They may or may not be perpendicular. Depends on the thing. They're adjacent. There's two angles.
They intersect. Well, no. Well,
And we do have an intersection.
They're supplementary.
They're supplementary. Okay, let's kind of unpack all of this because y'all gave me a lot of information. They're definitely adjacent angles. How many? Two. So a linear pair is going to be created by two adjacent angles. And these adjacent angles are going to form something very special. Yeah, this line. But since we're talking about angles, we're going to say that they form a straight angle. A straight angle is the same as a straight line. What's the measure of a straight angle?
180.
180 degrees. And so if I were to go through and add the measures of these angles, what would that add up to?
180.
They add up to 180 because a straight angle measures 180. And by angle addition postulate, I can take these two angles, add them together, and give me the measure of the entire angle. Now you had mentioned a word that said supplementary. Hold on to that. We're going to come right back to it. Questions on linear pair? All right. I'm out of room. If you have at least 4 lines or more on your page, you can continue. I need to switch pages, though. All right, so find the graphic that looks like this one. Whoops. You would, but you can't see it.
How much more space would you need for this one?
About 4 or 5 lines for this one.
Oh, okay.
Yeah. You can squeeze it in there. All right, take a look at these two angles. Ladies and gentlemen, if I could ask you to hold the conversations later, please. Thank you. Again, if you don't have this one, go ahead and draw it in. But if you're drawing it in, I ask please that you use a straight edge to make these angles perfect. Okay, so we have these two angles. Imagine for a moment we're going to grab this line segment ED and we're going to pull it so that it's resting right on top of BC. Can you imagine that?
Yeah.
And it's going to form this ray right here. What did we just make?
180 degrees.
180 degrees, a pair of adjacent angles that form the 180 degrees. What did we call that?
Linear pair.
Linear pair.
Linear pair. You're looking one step up from where we just were. So we created a linear pair, which means they add up to what angle measure?
180.
180. These are also going to add up to 180, but notice how they're not adjacent. When they're not adjacent and they add up to 180, we cannot call them a linear pair. We have to call them something else. Do you remember the name of angles that add up to give you 180 degrees? Say it. Supplementary, he said. We'll write it off to the right in just a moment. I'm going to give you a chance to finish this.
Is there anything supposed to be on the left hand?
Yeah, we're going to write supplementary angles on the left, but I'm going to switch it over in just a moment.
So, Miss,
Yes, sir.
going by this, all linear pairs are supplementary. but
Yes,
not
indeed.
All supplementary angles are linear pairs.
Correct. So what he said, I'll just repeat so that we can get it in. Since linear pairs add up to 180, and with supplementary we're not specific. We just say, hey, these angles add to 180. We didn't say that they had to be adjacent or not. This example, they're not. But in a linear pair, they are adjacent, but they still add up to 180, right? Right?
Yes, ma'am.
Which means linear pair are supplementary. But just because we have supplementary angles doesn't mean we have the linear pair. They have to be adjacent. And if they're not, all we can say is supplementary, and that's where we have to stop. That make sense?
Yes, ma'am.
All right. Last vocabulary word, and then we'll go on to the final example for the day.
What was it?
Supplementary angles, yes. This is the graphic for the last example. Now take a look at these. Imagine grabbing ED and sliding it over so it's on top of BC. What did we just create?
90 degrees. A line segment.
A 90-degree angle, yeah? You see it?
Blind right now.
It's okay. You see it now?
Yes, ma'am.
Yeah. All right, which means if we added these angle measures together, we would get a 90-degree angle. Do you remember the name of that relationship?
Complementary.
Complementary, he says. These are angles whose measures add to 90 degrees. Okay, I'm going to apologize for the handwriting now.
Oh man, wrong one, wrong page.
Uh-oh. Can you fix it?
No.
Scratch out and draw. There we go. These are complementary angles. Notice it's not specific as to where these angles are. They could be adjacent and still be complementary, or they can be on other planets and still be complementary. All we need to know is that their measures add up to 90 degrees. Go ahead and paste in your final graphic for the example. Those of you who may need to draw it in, I'll give you a few moments to do that. We're doing really good on time. We've got just under 20 left, and this is the final example. Everyone feeling okay if I get rid of complementary angles?
Yes, ma'am.
All right. Let me go ahead and write the directions for the example, and then we'll get right into it.
Give me my water bottle. It's right here. No. Calm down.
Okay, I'm going to zoom in closer on the example to make it a little easier to see. It reads, for what value of R are angle LKJ and angle GHI complementary? And then the same question, but we want to know when they're supplementary. So this question really has two parts and two answers. Since it has two parts, I'm going to go ahead and divide my workspace. On the left, I'm going to show the workout for the situation when they're complementary. And on the right, we're going to do when they're supplementary. When they're complementary, the angles need to add to what degree?
90.
And when they're supplementary? 180. Very nice. So we're going to use a little bit of the addition postulate. Remember, there's a sum of these angle measures, yes? Which means I get to add them together. So the measure of this angle plus the measure of the other angle must equal 90 degrees. I'm going to substitute for what I know. What is the measure of LKJ?
7R plus 5.
7R plus 5. I don't know what number measure that is, but I have an expression that once I figured out what R is, would tell me what that measure angle is. What is the measure of GHI?
8R plus 9.
8R plus 9. And that equals 90. I'm going to use my algebra skills. If you're already feeling comfortable with this, go ahead and do the work, solve it down. I'm going to go ahead and do step by step for those who might need it. I have like terms here, 7R, like 7 robots, and 8 robots here. I can add them together. 7 plus 8 is 15R. The 5 and the 9 are just numbers, so they're considered like terms. I can add them for 14. And my equation now stands like this. I want to get rid of everything around the R. Always get rid of addition, subtraction first. I'm going to undo addition with subtraction.
76.
76, thank you for the number. I was about to ask. 90 minus 14 is 76. When I have a number and a letter together, it means that I'm multiplying them. The opposite of multiplication is division. And so I'm going to use division to undo that multiplication. R equals, please don't give me a decimal.
Yeah.
Just leave it as a fraction right now. Yeah, I don't, if you can reduce it, if the fraction ends up being something like 2 over 4 and you can reduce that to 1/2, do it, but don't give me 1.5 yet.
You just divide by 3 and then give you the term.
I don't know if 76 is divisible by 3. If it is, then yes. Yeah, if it is, yes. I don't know if it is. I don't think it is.
It's not.
I'll send you someone else.
Yeah. No, but you're in the right spot looking for common factors to get rid of. You're in the exact right spot. And so I would urge you, if you think it's divisible by 3, give it a quick try in a calculator.
No, I just remember I was just thinking.
No, it's fine. You were in the right spot with your thinking. Thank you. All right. We're going to do the same thing with supplementary, and I want you to notice the similarities and the differences. Okay? Go ahead and set that up. I know that for some this algebra feels really simple. Go ahead and walk through the steps and do it. Look at those similarities and differences. Just if you're writing all these down, please. Do you mind passing this back? Thank you.
I called
Okay. Hey. Copy. Huh? Yes. Yeah, still copy it down anyway, just in case you're working on your homework or whatever, and you have something that looks like this thing you need to do, and you're just really tired and having a derp moment, and you're like, I don't remember how to do this. You have it here that you can follow along and remind yourself, okay? So even if you're feeling really comfortable with it, please still go through the steps. 166, you said?
Yes.
Thank you. Please go through those steps of writing them out anyway.
166 over 15.
Yeah, and again, I don't think that that can be reduced. If it can, reduce it. If it can't, leave it. And please don't give me decimals yet. Yet. All right. Questions on the algebra that we used to get here? Is it feeling comfortable? Give me a quick thumbs up. Feels more comfortable than it did yesterday? Or the same? All right. Give me a quick thumb sideways. I have no sideways. Okay, cool. Very awesome. Questions on complementary and supplementary angles, what those mean, how we use them? No? Awesome. All right. Thumbs up if adjacent angles, vertical angles, and linear pairs all seem good. All right, thumbs sideways if you want to talk with me right after lecture real quick, just to kind of review, make sure you're feeling comfortable with it. Let me see your votes right now. Okay, I've got a few thumbs sideways. Thank you for a thumb down. Appreciate you. Angle addition postulate, feeling a little better again? Thumbs up. Feels okay? Thumbs sideways feels exactly the same.
Oh, and Miss, while we're on this
Cool,
topic,
cool. All right, yes.
we would like all viewers to leave a thumbs up if you like the video.
that was awesome. Yes.
Doo-doo.
Thank you. Thank you very much.